All right, so now we've learned how to graph parametric equations. We've learned how to find tangent lines and find the first and second derivative of parametric equations. So the last and final thing we want to be able to do is find the arc length of parametric curves. So we want to know on the parametric curve how long is the length of the arc. So our outcome is I can find the arc length of parametric curves. So this is going to look familiar because you've done arc length already. But we just weren't in parametric, we were in equations, so we found arc length a little bit. So this is going to look somewhat similar when you see this. Now, we know parametric equations are where we have an x and a y equation, and they're related to each other by a third variable, the parameter. So that was just a reminder there of what parametric equations are that we've been working with. So here is the arc length of a parametric curve. So it is an integral from the alpha to beta, but from a to b of the square root of dx dt squared plus dy dt squared. So this looks a little similar to the other one when we weren't in parametric equations. Remember, it was 1 plus the derivative squared. So this is just if you have parametric equations. It is the derivative of the x in terms of t squared plus the derivative of y in terms of t squared, and then the square root of that. All right, now the important thing to remember when you're doing parametric curves, the same way it was before with other curves, was the curve has to be traced out only once on the interval by the parametric equations. So if you're going along a curve and then it comes back and repeats, you don't want to count that length twice. So you just got to make sure that on the interval that you travel along the curve only one time. All right, so let's take a look here. So it's just a straightforward formula is all it is. So find the arc length of the curve defined by the parametric equations. So we've got x is cosine, y is sine. This is going to be your traditional unit circle equations for parametric curves. And we're going from 0 to 2 pi, so that's going to be one full circle of the unit circle. So this is okay that we're only going to map out one time on the curve from 0 to 2 pi. So we don't have to worry about tracing out twice. So using the formula, it's the integral from a to b, so 0 to 2 pi. Then it is the square root, and we need dx dt squared plus dy dt squared dt. All right, so we need to do the derivative of x in terms of t. So the derivative of cosine t is going to be negative sine t. And then over here, you want the derivative of y in terms of t. So the derivative of sine is cosine t. All right, so now we're going to do our math here. So just keeping on plugging away, 0 to 2 pi, the square root of, so we square this, we get sine squared t, plus over here, you square that, it's going to be cosine squared t dt. Now, here's the nice thing. You know what sine squared plus cosine squared equals. That equals 1. Okay, right? Because that's an identity. Sine squared plus cosine squared is 1. So we're doing the square root of 1, which means we are integrating 1. Yeehaw. Real easy, easy, easy. So the antiderivative of 1 in terms of t is t, and we're evaluating from 0 to 2 pi. All right. So now you do the fundamental theorem of calculus. We put a 2 pi in there, subtract, put a 0 in there, and you get the answer 2 pi, which we know is the circumference of the unit circle, right? These parametric equations I gave you up here is the unit circle. The x value is the cosine, the y value is the sine. So this actually maps out from 0 to 2 pi. It maps out one circle, one time on the unit circle. And this has a radius of 1 unit. And we know the circumference is 2 pi r. So 2 pi times a radius of 1, so that's 2 pi. And that is the circumference of the unit circle. And we just did the integral for arc length. So we found the arc length starting here and going around the unit circle. And we found that that answer is 2 pi, just like it should be. So that's doing arc length. So let's try another one. Now, this one is the same problem, except notice what's different here. This is sine of 2t, and cosine of 2t, which means when you put this interval in here, it's going to go from 0 to 2 pi. It's going to go from 0 to 4 pi. So that means you're going to have gone around the circle twice, okay? So again, I'm going to say it again. On this interval from 0 to 2 pi, when you put those numbers in here, you're going to double them. So it ends up meaning you're going from 0 to 4 pi. This is still sine and cosine. This is still the unit circle. So if I go 4 pi, that means I've gone around the circle twice, okay? So that means I don't want to do 0 to 2 pi when I do the arc length, because that will count going around the circle 2 times. Now, I could do that and just divide my answer by 2 if I'm smart enough to know I've gone around the circle 2 times. All right, so you could do it either way, I guess. You could do 0 to 2 pi and then take half your answer, or when you do your arc length, or L, I just did A for arc length, you could do the integral from 0 to pi instead of doing 0 to 2 pi. All right, so again, this is going to be dx dt squared plus dy dt squared dt. All right, so make sure you understand why we're going from 0 to pi. So I want dx dt, I want this derivative. So the derivative of sine is cosine 2t, and then you have to chain on the derivative of the 2t. And then I want the derivative of y, so that's going to be negative, let me put the negative over, negative sine 2t, and then I got to chain on the derivative of 2t, which is 2. So that's the derivative of this. So now to find my arc length, because that does look weird because it looks like area. So arc length, L for arc length. Woo! All right, so now I'm going to go from 0 to pi. So what do I get here? When I square this out, I'm going to get 4, because I got to square the 2, cosine squared 2t, plus, and then I'm going to square this, so negative 2 squared is going to be 4 sine squared 2t dt. All right, so then from 0 to pi, if I factor out the 4, I've got cosine squared 2t plus sine squared 2t dt. And this is an identity. Cosine squared plus sine squared, this equals 1. So that means I'm doing the integral from 0 to pi, 4 times 1, so this is the square root of 4, so this is going to give me 2. All right, so again, when you factor this 4 out, you're left with cosine squared 2t plus sine squared 2t. This is an identity, cosine squared plus sine squared of this, as long as the angle is the same. This equals 1. So 4 times 1 is 4, and the square root of 4 is 2. So now I'm just integrating 2 from 0 to pi. So the antiderivative of 2 is going to be 2t. I'm evaluating from 0 to pi. So now we do the fundamental theorem of calculus. So we put a pi in there, that'll be 2 pi. Then we put a 0 in there, gives a 0. So the answer is 2 pi. Now, I told you up here at the top that the answer should be 2 pi. So if I'd have done the integral from 0 to 2 pi on my limits of integration, I would have been putting a 2 pi, which would make the answer 4 pi, which means I've gone around the circle twice and I've counted that arc length twice, which would be the wrong answer. All right, so you just have to caution and make sure you know and understand, and make sure that on the interval they give you, that these parametric equations only map out the curve one time, that they don't retrace each other or backtrack on itself. All right, now the way you can do that is you can, like I taught you, put the equations in a calculator and have it graph it and watch it graph it to see if it backtracks on itself. All right, so you can do that if you're not sure. Okay. All right, the next one. So this one says, number 3, find the arc length of the curve defined by these parametric equations. Now they're actually asking me to do 0 to 3. With these type equations, going from 0 to 3, if you put a 0 in here and any number up to 3, this y coordinate is going to be different every time. So there's no reason for me to think that this is going to backtrack on itself. So I'm actually going to do my arc length, and I'm going to go 0 to 3. There's no reason to think that this one would. Usually it's the trig ones with the sine and the cosine that sometimes will backtrack on each other. All right, so I want to do the square root of dx dt squared, the dx dt, yeah, plus dy dt squared, and then dt. All right, so we just have to fill in those. So I need the derivative of this. So I need dx dt, the derivative. So the derivative of e to the t is e to the t. And the derivative of e to the negative t is e to the negative t. And then you got to chain on the derivative of your exponent, which is a -1. All right, and then we need the derivative for dy dt. We need the derivative of this, which is going to be -2. So all I did was I found the derivative dx dt. So I took the derivative of this in terms of t's, and then I took the derivative of the y function in terms of t's. So this is dx dt squared, and this is dy dt squared. All right, so the rest is algebra. All right, so we actually need to square this out. So if you remember how to square a binomial, you square the first term. So that's going to be e to the t squared, which is e to the 2t. You square your last term. So this last term squared is going to be a positive. And then when you square this, this is going to be e to the -t squared, which is going to be e to the -2t. Because when you raise a power to a power, you multiply. So you're really just multiplying these guys by 2's. Now we need the middle term. Now to get the middle term, when you square a binomial, you multiply these together and then double it. So when we multiply these together, it's going to be a positive times a negative. So this is going to be a negative. And when you multiply e to the t times e to the -t, remember when you multiply powers, you add the exponents. So when you add t and -t, you get 0. So this is going to be e to the 0, which is 1, and then you're going to double it. So that's going to give you -2. Now, if you're not sure about that, here's what I would do as my suggestion. All right. If you're asked to square a binomial like this, then that means you should really write it out. E to the t minus e to the -t times e to the t minus e to the -t. You should really write it out twice when you square a binomial, and then do first, outer, inner, last, and actually multiply it out if you're unsure. All right. But the short way to do it is to square the first term, square the last term, and then multiply them together, and then double the answer. All right. Then over here, this is just going to be -2 squared, which is 4. So I don't need this big long line. So that'll give me dt. Now, look what we have. When we combine this together, we have the square root of e to the 2t. Then this +4 and this -2 is going to become a +2. And then e to the -2t. So I'm just combining these terms, and it gives me +2 in the middle. Now, compare that, and this happens a lot, compare that to what I have up here. This expression looks just like this one. The only difference is the 2 is a plus. This expression is the square of this guy up here that has a minus sign in it. So now, this expression is a perfect square. It's the same as this, but with a plus sign. So it's e to the t plus e to the -t quantity squared. So it's this same binomial, except with a plus sign in it instead of a minus sign. The minus sign is what made this a -2 in the middle. So if I change that to a plus, it's now going to be the same thing, just with a +2 in the center. So when you add this 4 to it, it creates a perfect square, the same as this binomial up there with a plus sign. All right, which means now we have something squared and we're taking the square root of it. So the square root and the squared cancel, so I'm just left with e to the t plus e to the -t dt. All right, so now I'm ready to do the antiderivative. So the antiderivative of e to the t is e to the t. The antiderivative of e to the negative t is negative e to the negative t, because if you take the derivative of this, you're going to chain the negative 1, which is going to make it a plus. So this is the derivative of that. And we're going to do fundamental theorem from 0 to 3. So I did the antiderivatives, and now we're doing the fundamental theorem of calculus. So I put a 3 in first, so e to the 3 minus e to the negative 3. And then we're going to put zeros in there, so e to the 0 minus e to the 0. All right, so obviously e to the 0 minus e to the 0 is 0, because that's 1 minus 1. So my answer is e to the 3 minus e to the negative 3, which if I want to rewrite that, that would be e to the 3 minus 1 over e cubed. You could write it that way if you want to. And you could also type that in your calculator, e to the third power minus 1 over e to the third power, and get a decimal. And then you could double check your answer by math nining the original problem and making sure that your answers are indeed the same. But we should be able to do some of these longhand like I've been doing instead of math nining them. All right, so we have one last problem to do. So again, this is nothing but a formula, is all it is. We are just doing a formula, doing the integral of the square root of dx dt squared plus dy dt squared. It's all you're doing. All right, now this says find the length of one arch of the cycloid on the interval from 0 to 2 pi. Okay, so this is our interval because they're telling us one arch on this interval. All right, so I don't need to change the interval length or anything. Now, there's a hint here that says use the fact that sine squared of theta divided by 2 is equivalent to 1/2 1 minus cosine theta. We need to use that. Remember to use that here in a second. All right, so for this one, we are still going to do our arc length because that's what it's asked us to do. And we're doing it one arch on the interval from 0 to 2 pi. And we know this is going to be dx dt squared plus dy dt squared dt. So the hard part about this problem, here's x, we need dx dt. So some of these, I suggest you figure out your derivative before you do your formula. And we need dy dt. So we need the derivative of this, okay? So to do the derivative of this, I suggest multiplying this out because we have a product. So x is equal to r theta minus r sine. All right, over here, y equals, distribute this out, r minus r cosine. So I need the derivative of this. So in terms of thetas, excuse me, this should be thetas. I think I've done that on another problem earlier too, but all right, so dx d theta. So dx d theta, I want the derivative of this in terms of thetas. Now remember, r is a number, not a variable. So this is like 3 theta. So the derivative of 3 theta would be 3. So the derivative of r theta is going to be r. And then minus, r is a number. The derivative of sine theta is going to be cosine theta. So that means dx d theta, which is the same as your dx dt, it's just our variable we're doing is a theta, not a t, is going to be r minus r cosine theta. That's what goes there, and we're going to square that. Now we need the derivative of our y1 in terms of theta. So the derivative of r, that's a number, so that's 0. Then negative r, that's a number. The derivative of cosine is negative sine, so it's going to end up making a positive sine theta. So the derivative of r is 0, so that goes away. So the derivative of this part is going to be a positive r sine. So that goes in here, r sine. So this is our derivative of our x. This is the derivative of our y. So in our arc length formula, you have to square those two derivatives, add them together, and then take the square root. So we've got a lot of algebra here to do. All right. So the first thing we're going to do is square. We're going to square each of these binomials. Well, that's not a binomial, but we're going to square this binomial. So how do you square a binomial again? You square the first term, r squared, square the last term. So that's going to be, how much space do I need? Okay. So that's going to be r squared cosine squared. And it's positive because you're squaring a negative number. So when you square this, you get r squared cosine squared. To get your middle term, you're multiplying these together. So that'll be r times this guy, and you're going to double it. So that'll be negative 2r squared cosine. Because you're multiplying these together and doubling it. So I'm multiplying r times this term, which is going to give us a negative r squared cosine, and then I'm doubling it, negative 2r squared cosine. Again, if you cannot do this the short way by squaring the first term, squaring the last term, and then multiplying it and doubling it, then I suggest you write these out separately. Write it as r minus r cosine, r minus r. Let's see, let me make sure I write it correctly. This should have a cosine in it. R minus r cosine. Write it out twice because it's being squared. So write it out twice and then do first, outer, inner, last, and to get this. All right, so over here, we're just squaring this term. This is one term, so we square this, we get r squared sine squared. All right, so now we're going from 0 to 2 pi. The first thing I'm going to notice here is in this right here, I have r squared cosine squared plus r squared sine squared. So if I factor out the r squared out of this, I'm going to be left with cosine squared plus sine squared. Oops, this has to be a theta. All right, so if I factor out the r squared, I'm left with cosine squared plus sine squared. We know what cosine squared plus sine squared equals. This happens a lot when you have the sines and cosines in there. So cosine squared plus sine squared, this equals 1. So I just got r squared times 1. So now we have 0 to 2 pi. Inside here we have r squared minus 2 r squared cosine plus an r squared. Okay? So now, when I add this together, and we'll add my like terms here, I've got the square root of 2r squareds, because we're adding r squared with this r squared, so I have 2r squareds minus 2r squared cosine. Okay? Give myself plenty of space instead of keeping on going. All right, so now you'll notice both of these terms have a 2r squared in it. So if I factor out the 2r squared, I will have 1 minus cosine theta. Okay? So now this is where we need to use the little hint that was given at the top of the page. This says 1 minus cosine theta. So let's go back up to the top of our page. If I can scroll back up there on that little hint right here. I have 1 minus cosine theta. So it says sine squared of theta divided by 2 is equal to 1/2 1 minus cosine theta. So that means 1 minus cosine theta is equal to 2 of these. Theta divided by 2. All right, so 1/2 of 1 minus cosine theta is equal to sine squared theta divided by 2. So if I multiply the 2 to the other side, then that means 2 sine squareds of theta divided by 2 is equal to 1 minus cosine. So I'm going to replace my 1 minus cosine with 2 sine squared theta divided by 2. All right, so that's going to come down here and do. So I've got 2r squared, and I'm replacing my 1 minus cosine with 2 sine squareds of theta divided by 2. Okay? So I'm just replacing that. So now what do you get? You get a perfect square, which makes everything, all this algebra turns out just beautiful. All right? So now when I multiply this together, I get 4, which is 2 times 2, 4. I get an r squared, And now we have sine squared of theta over 2. So now everything underneath my square root sign is a perfect square. So that means I can just take the square root of everything. So the square root of 4 is 2. The square root of r squared is r. The square root of sine squared is just sine. And the angle is theta over 2. That didn't change. All right. So now we need our antiderivative of this now. So remember, 2r is just a number. So I'm going to keep my coefficient. I need the antiderivative of sine. The antiderivative of sine is negative cosine. So this will be negative cosine. All right. And my angle is theta over 2. Now remember, when you take the derivative of this, you're going to multiply by 1/2. So since I'm integrating, I need to multiply by 2. So when you take the derivative of something, you chain on the derivative of the angle. So we would chain on a 1/2. So going backwards, I need to multiply by 2 because we're reversing. We're going backwards. So what have we got? Whoops, I don't need my d theta anymore. So now we're going to evaluate. This is my antiderivative. We're evaluating from 0 to 2 pi. So what have we really got here? We have negative 4. So when I'm doing my fundamental theorem of calculus, this is negative 4r, and we're doing the cosine. Put a 2 pi in first, so 2 pi divided by 2 would just be pi. And now you're going to put a 0 in here, so we're going to have negative 4r cosine, and you're putting a 0 in here, so 0. So you're going to end up with, what's the cosine of pi? Cosine of pi, this is negative 1. So this is going to make positive 4r because you're going to have negative 4r times negative 1. And then here, the cosine of 0 is positive 1. So this is going to end up being plus 4r times 1. So that's 4r. So our final answer is 8r. That's our final answer. Now, that means depending on what the radius is for this particular problem, this cycloid that we're doing, remember this was that generic equation of a cycloid with whatever radius r we want it to have. So r can be any radius number. So this is a general formula for a cycloid. Okay, so we found the length of one of the arches of a cycloid, and a cycloid, you know, does this. So what we want to do is, if our radius was 3, then that means that arc length of one of those arches is 24. If the radius was 5, then that would mean one of the arc lengths of one of those arches is 40. So it just depends on what type of cycloid you have, what its radius is, would determine the length of each of the arches. All right, so that depends on r. So the length of it is 8 times r, whatever the radius is on the particular cycloid that we have. All right, so this is just doing a formula. We are integrating the square root of dx dt or dx d theta, depending on what your variable is, squared, and then dy dt or dy d theta, the derivative of the y expression squared. And that finds you the arc length. The only suggestion, or the only thing I caution you about, is watch out limits of integration, because you don't want the curve to backtrack on itself so that you are counting the arc length twice or something. If your particular parametric equations overlap each other and come back and travel over each other again, you don't want the total distance traveled. You want just the length of the arc. So you just got to watch and make sure that the actual interval is actually just mapping out one length of the arc and not backtracking on itself. So that's the only thing that you have to caution about with these particular problems and do an arc length of a parametric equation. All right, so I've just given you 1, 2, 3, 4, 5 problems to do. So you can work on those 5 problems. And if you have any questions, of course, I will answer those and go over some of those in our Zoom time. So good luck.